Hello students, welcome to this small video clip on synthetic organic chemistry. Now I am teaching a chapter that is Tautomerism and Enolates. The topic I am going to teach today is a small synthetic applications of malonic ester. Now organic chemistry is perceived as a tough subject by many students. In this video, I want to show that how learning organic chemistry is more fun. So here I'll be teaching only 4 reactions. Prior to that, I'll teach you what is the fundamental of these 4 reactions, what's the common thing about all these 4 reactions, and so that you can learn organic chemistry, enjoy it, and learn this. So let's start now. I want to teach you on Tautomerism and Enolates, and the small topic that I have taken is what are the synthetic applications of this compound, that is diethyl malonate. Now diethyl malonate is this compound. This is your diethyl malonate, and this compound, you know that, has an active methylene group. This is called as methylene group. Why do we call it as active methylene group? Is that this CH2 is flanked by 2 carbonyl groups. These are the 2 carbonyl groups. Here, these 2 are the carbonyl groups. In any carbonyl group, you know that there is minus delta on the oxygen. There is plus delta here due to this polarization, and these 2 hydrogens, we call it as acidic in nature because this can leave the molecule as a proton. So it gets protonated. So this is the common term thing that happens in all tautomerism, and diethyl malonate is one of such compound which has ketoenol. We call this as, if this hydrogen goes there, what happens? It becomes a OH group, and these electrons move on here, giving rise to a double bond. So there is always ketoenol tautomerism in all these compounds. Now you can see that in all these 4 synthetic applications of malonic ester, there is one thing that is common, that is we are always converting, in all of them, converting diethyl malonate. What is this diethyl? There are 2 ethyl groups. This is an ester of malonic acid, therefore this is diethyl malonate, is always converted into a sodium salt of the diethyl malonate. A sodium salt is more soluble, and therefore it becomes very reactive. It can react with alkyl halides and give rise to many compounds which have a lot of synthetic applications. Now in all these 4 reactions, I will be using conversion of diethyl malonate to this sodium salt, which I have written here. You can see that here, this is a common reaction in all of them, where I am converting the diethyl malonate reacting with sodium ethoxide, which is a basic compound, and this gives sodium salt. Because this is reactive, there is polarization in the molecule. It can react with alkyl halide depending on what is the compound that I want. I will be changing this R group as I want it. So it can be tailor-made, and I can get various other products. So let's start. Now coming back to how are we converting this diethyl malonate to our desired product, that is butanoic acid, that is monocarboxylic acid. There is only one carboxyl group, therefore how do I get it? So first I reacted with sodium ethoxide. You know that this is polarized. There is a positive charge This is a negative charge. We know that positive charged compounds, they will seek electrons, and this negative charge compound will seek a positive center. Therefore, these we call them as nucleophiles. They will go wherever there is less electron density. Therefore, it will seek a positive center. So now when I react with this diethyl malonate with my sodium ethoxide, this acidic hydrogen which has gone there now, this hydrogen is substituted by this sodium. Next, when I react it with ethyl iodide, which is my alkyl halide, now this very electropositive sodium interacts with iodide, which is very electronegative. Why? Because iodide will always leave the molecule with its pair of electrons and combine with the sodium. Now what happens to this ethyl group? So therefore there will be a positive charge on this one of the carbons of the ethyl group, and that positive charge will go and attach here. So that's what is happening here. This has got attached to this point. So I have got this intermediate. When I hydrolyze this compound, hydrolysis is breaking up a ester bond here, and OH attaching here, H is attaching here. So when I hydrolyze, I get the carboxylic group. So I have two carboxylic group, but I want only one carboxylic group in my product. Therefore, what do? I remove this carbon dioxide. So this removal of carbon dioxide, we call it as decarboxylation. So when I heat it, this salt, I take it, I dry distill it, I heat it, carbon dioxide leaves, and I get back butanoic acid. That's what I'm supposed to do. How I convert my diethyl malonate to butanoic acid. Now there's one carbon, second, third and fourth, therefore this is butanoic acid. Okay, now let's go to the second synthetic procedure. Now this is how am I going to synthesize dibasic acid. Dibasic acid, as you can see, that has two carboxylic groups. I want adipic acid from my diethyl malonate. So here you can see that I have directly taken the sodium salt. Therefore, you will have to incorporate this equation, which is common. How do? I react with sodium ethoxide, I get the sodium salt. I take this sodium salt and interact with 1,2-dibromoethane, 1 and 2-dibromoethane. You can see that the very electropositive always interacts with electronegative. Therefore, you have sodium bromide eliminated in this reaction, because the bromine would leave the molecule along with its electrons, and there is a positive charge. Therefore, this acts as an electrophile. There is electron rich here, therefore this is the nucleophilic center. As a result, this will attach to these two carbons, this CH2 here and this CH2 here. So I get this intermediate. Now when I hydrolyze, as before, I can break this ester bond. That's what I've been doing here. This ester bond is broken down. So here again there is addition of H and OH. So on hydrolysis, I get dicarboxyl. Each carbon I have two carboxylic groups attached. So now I have to get rid of one of the carboxylic group. I heat it, take these crystals, it's called dry distillation, and heat it. I have two molecules of carbon dioxide eliminated, and I get my desired product, that is adipic acid. You have already studied in your carboxylic acids how to write the structure of oxalic acid, malonic, succinic, glutaric and adipic acids. Learn that. so that it becomes very easy for you how to write the structure of adipic acid. It has 6 carbons. I hope you have understood this. Now we have finished with 2 synthetic conversions. That is, how am I converting diethyl malonate to butanoic acid, and then how I am converting this into adipic acid. Now let's go to the third conversion. That is, how do I get butanone from my malonic ester, diethyl malonate. It is an ester because malonic acid is nothing but I have CH2, COOH, this is my malonic acid. It has interacted with ethanol and given diethyl malonate. Now let's start with this. Now I take, as usual, interact my sodium ethoxide, which we call it as a strong base, with this. A base will protonate this hydrogen, it will remove this hydrogen. So as a result, the hydrogen goes with an ethoxy group and forms ethanol. It's eliminated. The sodium goes and attaches here. So I have got this reaction, that is sodium salt of diethyl malonate. Now we can take the required alkyl halide. Now since I want butanone, I will be taking propionyl chloride, this is the compound, propionyl chloride, which is CH3, CH2, COCl. Ethyl group here, CH3, CH2, COCl. That's my propionyl chloride, which is nothing but an alkyl halide, propionyl chloride, and interact with this sodium salt. What do we expect? The very electronegative chlorine will attach to the sodium, eliminate as NaCl. Because this is gone, there is a positive charge here, you know that already, that there is a pair of electrons. Therefore, this is the nucleophilic center. Because this carries a positive charge, therefore this is the electrophile, this will go and attach here. So I get this intermediate. Now, as usual, I will carry out hydrolysis where there is breaking of this ester bond and it's converted into carboxylic group. You can see that there is elimination of ethanol, 2 moles of ethanol from here, and it is converted into carboxylic group. When I have to decarboxylate, I will heat it. I will lose 1 carbon dioxide. So this carbon dioxide is lost. So I get this compound, this H goes here. Therefore it's C2H5, CO, CH2, COOH. I still have a carboxylic group. So I carry out another decarboxylation, lose this carbon dioxide also. Therefore this H combines with this, giving me CH3. So what did I get? C2H5, CO, CH3, which is nothing but our butanone. So this is the other synthetic application of our compound, that is diethyl malonate. Now let's come to the last synthetic conversion. How do I convert diethyl malonate to a cyclic compound? You can see that this is a cyclic compound. What is a cyclic compound I want? Barbituric acid. Now this is a drug, it is a sedative. Okay, sedative drug. You shall be learning about lot of organic chemistry in next year, which is paper 5 is full of organic chemistry. That's the reason I want you to learn organic chemistry well. So going back, this I have diethyl malonate. I interact with urea. Now this compound is urea, and this is my diethyl malonate. So here urea has two amino groups. Instead of writing NH2, I have written NH such that elimination can be shown. When diethyl malonate interacts, you have, once again, why this happens? Because there is polarization in the molecule. This is always minus delta. Therefore, this hydrogens, there is positive charge here. Oxygen is electronegative. Therefore, it will leave the molecule along with this pair of electrons and combine with a proton, eliminating ethanol. Ethanol is leaving the molecule. Therefore, this condenses, so it forms a reaction wherein there is addition reaction, wherein this NH is getting added to this position. Therefore, I have CH2, CO, NH, CO, NH, CO, that is your barbiturate acid. Now this, you may feel that how am I going to write the structure of barbituric acid? You just have to know that it is as simple as writing the structure of diethyl malonate and where the bond is leaving. Therefore then after you eliminate this, you just have to join this NH, and that's how you got the barbituric acid. What's the function of that? It's a sedative. Therefore, it's a drug. Barbiturates are habit-forming drugs which is taken for sedation. So I hope you have understood. I will once again take a summary of this. First we did how to convert diethyl malonate to butanoic acid, then to adipic acid, then to butanol, and then barbituric acid. Please keep in mind that in all these reactions, many of them we are starting with reaction with sodium methoxide and getting a sodium salt, except for the last one. Okay, and here we are interacting two such sodium salts such that I get adipic acid. Hope you have understood this synthetic applications of diethyl malonate. Please go through the notes. Given you the notes, they are all very important to understand the fundamentals of organic chemistry. I hope that this video was useful. Thank you.